The next insertion method in the doubly linked list is inserting the new node before the given node. Okay, so in a previous video we saw about inserting the new node after the new node after the given node, and now we are going to insert the new node before the given node. Okay, so consider this linked list, and here by using the data in the node only, we are going to check the condition same as the previous method. So here also we are checking the condition, that is ptr tends to data is not equal to value. Okay, we are checking this condition. So for example, I'm taking is the 3. Okay, if it is 3 means what will happen, the condition will become false. Then before we are going to insert, right? So we have to insert here. So with the value 6 means we have to insert like this. Okay, so we will see this. We have to insert like this. Okay, so we will see with the code. So this is the code we have taken. Okay, so here we are using 2 pointers, new node and the ptr, then 2 variables, that is value and the num. So by using the scanf statement we are getting the value of the num, so consider num is equal to 6, and then enter the value before which data has to be deleted. So I'm giving the value val is equal to I'm giving as 3. Okay, now by using this statement, what we are doing, we are allocating the memory space by using the malloc function for the new node. Then we are assigning the data. So just I will draw the new node here. This is the new node. Okay, this is a new node. New node tends to data is equal to num. So new node is equal to data is equal to num 6. So the value 6 is assigned in the new node. Then what we are doing, we are assigning ptr is equal to start. So this is a start node. Okay, so we are assigning this is a ptr. So this is a ptr node. Okay, next we are checking the condition like last method. ptr tends to data is not equal to val. So we have to check the condition. So what we are check the condition, ptr tends to data is not equal to val. So what is the val value? 3. So we have to check this condition. So we are using as a while loop. If this condition is true means what will happen, the statement this will be executed, that is ptr is equal to ptr tends to next. ptr is equal to ptr tends to next. So we will check. So this is a ptr node, and what is the data? It is 1. So we will check the condition, 1 is not equal to 3. This condition is true. So what will happen, this statement will be executed. So ptr tends to next is ptr is equal to ptr tends to next. So what will happen, so now this is a ptr node. Next again we are checking ptr tends to data. So here data is 2. So 2 is not equal to 3. Yes, condition is true. Then we are moving pointer to the next node. So here we are checking ptr tends to data, it is 3. 3 is not equal to 3. So this condition is false. If this condition is false means it will come out of the loop and it will check the next statement. So these 4 lines should be executed. Okay, so before explaining this, just for better understanding, I will give the address for each and every node. So consider for this chart node it is 201, and for this it is 105, and it is 210. Okay, and here it is 107, then it is 104.3, and here for new node it is 200. Okay, so address part. So let's check what will be the address here. So here the next node address, so it is 105. Okay, this 105, and here it is previous node address, so it is 201. Here the next node address, so 210. Here the previous node, so it is 105. Here next node 107. Then here previous node it is 210. Here next node it is 103, and here it is previous node, it is 107. Okay, then here new node tends to, next is PTR. So this is a new node, and next means here PTR node address. What is the PTR node address? It is 210. So next is 210. And next statement, new node tends to previous is equal to PTR tends to previous. So this is a new node tends to previous part. For this, PTR tends to previous. So this is a PTR node, and what is the previous node? This one. What is the address? It is 105. So this is 105. And next, PTR tends to previous tends to next. So PTR. So this is the PTR node. PTR tends to previous, so this one, and this one next is this particular part. So what will be that? It is new node. So what is the new node address? It is 200. So I am writing here it is 200. Then next, PTR tends to previous. So this is the PTR tends to previous. What should be that? That is a new node. So what is the new node address? It is 200. So like this way the node is inserted before the given node. And this is the code and algorithm. Okay, so first we are checking overflow condition, then allocating the creating the new node and allocating the memory space. Then what we are doing, we are assigning the value for the new node. New node tends to data is equal to value. Okay, then PTR is equal to start. Then we are checking the condition. Okay, then we have to allocate the address. We have to change the address, right? After doing the insertion for the previous and next, we have to change the address. So by using these four statement, by using this four statement, what we are doing, we are allocating the memory address for each and every link. So by using new node tends to next, this PTR, the same line only we are using. The new node tends to previous equal to PTR tends to previous. Then PTR tends to previous next tends to next is equal to new node. So here, then PTR tends to previous is equal to new node. So like this way, what we have to do, we have to insert the new node before the given node. So here mainly we have to check this condition. Okay.